Today we're going to be learning about factoring GCFs, and our objective is that we will be able to factor the GCF out of a polynomial. So let's start with some vocabulary. Factor as a verb means to rewrite an expression as a product. And remember, product is when you multiply two things together. Factor as a noun is something that divides evenly into something else. For example, 5 is a factor of 10 because 10 can be divided by 5. GCF stands for the greatest common factor. How do you factor GCF out of a polynomial? You're going to divide all terms by the GCF. I sometimes call it undistributing because basically it's the same process as distributing, except for we're dividing a term out instead of multiplying a term in. So let's look at some examples. Our first example, 5x cubed y squared plus 20x to the 6y cubed minus 10x to the 4th y. So the first thing we need to do is determine the GCF of this polynomial. First thing I'm going to look at are my coefficients. So I have 15, 20, and negative 10. Well, the largest number that divides evenly into all of those would be 5. Next, I'm going to look at my x part of each term. And I like to describe this in a way that talks about money, because for some reason, students understand things better when money is involved. So if I look at the first term, it's got x cubed. Let's pretend that means it has $3. The second term has x to the 6. We're going to let that be represented by $6. And finally, x to the 4th, I'm going to represent with $4. So, if each of these terms were people, and we're saying they're all going to have to chip in the same amount of money, and we want to get the most money possible, this one only has $3 to give. So we're going to take all $3. We can take $3 here as well, and $3 here as well. That helps us say that they all have x to the 3rd in common. We'll use a similar idea with the y's. This one has 2 y's being multiplied, 3 y's being multiplied, and 1 y being multiplied. So this only has 1 y that it can give. Both of these can also give 1 y. So we just put a single y in our GCF. Now we are going to divide each term by the GCF. Since we divided it out, it's going to go out in front of our parentheses. And then inside, we'll have the results of our division. 15 divided by 5 is 3. X to the 3rd divided by x to the 3rd would be 1. They cancel out, so we won't have an x in our first term. Y squared divided by 1 means we had 2 y's being multiplied. We divided 1 out, so there's 1 left. 20 divided by 5 is 4. x to the 6 divided by x cubed. We had 6 x's, we're dividing 3 of them out, so 3 of them will be left over. You're subtracting the exponents. So here we had y cubed, we're dividing out 1y, so we would have y squared left. Finally, negative 10 divided by 5 would be negative 2. We had x to the 4th, we're dividing out x cubed, so there's just an x left, and y divided by y would be 1. And that's our final answer. If you ever wanted to double check your answers, you could take your GCF that you factored out, distribute it back into all the terms, and you should get back to the original problem. In our second example, we're going to start by looking at the coefficients. 3, negative 12, and 9. All 3 of those are divisible by 3. Then we look at our variables. We've got an a squared and an a, but there's no a in our final term, so we can't put an a as part of our GCF because it's not part of all 3 terms. Similarly, our second term has a b and our third term has a b squared, but our first term didn't contain a b, so we can't put a b in our GCF. So this time, our GCF is just a constant. I'm going to divide each term by our GCF. It still goes out front, and I'll be left with a squared minus 4ab plus 3b squared. So again, we're going to start by finding the GCF. First, we're going to look at the coefficients. (7), negative 11, and negative 14, the only thing that all 3 of those are divisible by is 1. Our first 2 terms have c's, but the third one doesn't, and the third one has an m, but the first 2 don't. So our GCF is just 1. And what happens when we divide anything by 1? Well, it stays the same. So we can just leave our answer the same. You could also put the 1 out front. And write it like that, but typically we just leave it the same as the original problem if the GCF is just 1. For our last example, go ahead and pause the video for a second and see if you can come up with the GCF on your own first. Let's see how you did. 28, 14, and 7 are all divisible by 7. Then we have x to the 5th, x cubed, and x squared. So our greatest common factor between those would be 2. How'd you do? Now we're going to divide each term by 7x squared. Don't forget to write it outside your parentheses. 28 divided by 7 would be 4, and we'd be left with x cubed plus 2x, and finally plus 1. 7 divided by 7 equals 1, and we need it there at the end. A hint is that when there's 3 terms in the original problem, then there should be 3 terms inside the parentheses, because we said the way of checking our answer was to distribute the GCF that we took out back into our parentheses. If we don't have the 1 there, if we just drop it because they cancel out, when we distribute, we'd only get 2 terms when we should have 3. That's all for today. See you in class.